Good evening. Today is Tuesday, February the 23rd. Today in pre-calculus, we're looking at vectors and we're looking at combining vectors. So I'll share my screen and show you an example of how you can combine three vectors using the components so that it's much easier to use the component form rather than what we would call a parallelogram form. So I'll show you how to do this. Now, so if we look, when you're looking at vectors, we're going to draw our axis here. So we've got our axis that looks like this. And we'll come across here. So this is our x-axis. Now, you have vectors in standard position. So we're going to look here. We're going to start with a vector, which starts here at the origin, and it goes up this way. So we're going to say this is a 20 unit vector. So it's a length of 20. And the angle that it makes with the positive x-axis is 30 degrees. Okay, now we have a second vector here, which we'll say goes down here into the fourth quadrant. So it goes down like this, and let's say this vector is going to be 10 units. So I try to make it about half as big. So this is going to be 10 units. And the angle here is going to be 65 degrees. Right? And then the final vector here, that's a degree symbol. The final vector here will go off into the second quadrant here. We'll say this one is about 15. So it has a magnitude of 15, and the direction here is 10 degrees. Now, what you're looking at here, when you're looking at components, so we come up here and do our color here. Say, we can look at the horizontal components. So the horizontal component for the 20 unit vector goes right about like that. And then if we put the arrow on it, okay, now the horizontal component for the 10 unit vector here goes from the same point, but it goes about, I'm going to do that. So I come up, so it starts at the same point and goes about like that. And then the horizontal component for the 15 unit vector starts here and goes this way. So it looks like that. Now, the other components, if I come in here, let's say the other components, we'll make the vertical components blue. So we come in here, so now the vertical component of the 20 unit vector is right there. Here's the vertical component for the 10 unit vector, and here's the vertical component for the 15 unit vector. If I put the arrows on the top of each one of those. Now, so what I'm going to do when I'm doing a component method here, I will go back now and change this to X. So I'm going to have my X components, and we'll do it over here so we got a little room. I'm going to do my X components, and then I'm going to do my Y components. Now here's the thing. See, if I look, anytime I have an X component here, it's going to be the magnitude of the vector times the cosine of the angle. So the cosine of 30. And then the Y component or the vertical component is going to be the magnitude of the vector times the sine of the angle. So now that's the case in every situation. So if I look, I've got for my first component for the 20 unit vector, I've got 20 cosine 30 and for my y component, I have 20 sine 30. And then the same thing happens for my 10 unit vector here. The x component is 10 cosine 65, because 65 is the angle. Now notice in this case, see, both the 20 and the 10, the x components are going to the right, so that's positive. But when I get over here to the 15, I'm going to have it's going negative, so I have minus 15 times the cosine of 10. Okay, and I'll come back in a second and I'll add all these up. Now, in the y components here, see, this one is positive, this one is negative, so I have minus 10 sine 65 and then over here for the 15 unit vector, that's going positive, so that would be 15 sine 10. Okay, so now once I get all this done, I put these two in my calculator, and I get an answer here. So if now when you do your calculator, make sure that you check your mode and make sure you're in degree mode, which I am. So I have 20 cosine 30 plus 10 cosine 65 minus 15 cosine 10, and I get an answer of 6.77. So this is 6.77. Right now, if I do my y component, I do 20 sine 30 minus 10 times the sine of 65 plus 15 times the sine of 10, and I get an answer of 3.54. So here I have 3.54. Now, once I have this, now I know the resultant vector, the components. So if I come up here, see, in my x direction, I'm going 6.77. So that is 6.77. And then in my y direction, I am going 3.54. So I start here and I go in my y direction, 3.54, which is about like that. And then I draw my triangle from here to here, and that right there. So now what I see is I have, this is my 3.54. And then I have my resultant vector over here, which is what the hypotenuse of this triangle is. So then I can come in here. Now, to find the magnitude, I do the Pythagorean theorem. So I do the square root of 6.77 squared plus 3.54 squared. and I get an answer of 7.64. So my hypotenuse here is 7.64. Now, to get my angle here, which is right in here, I do an inverse tangent. So I do a tangent minus 1, inverse tangent of the opposite side here, which is 3.54 divided by 6.77, and I get an angle of, if I put this in my calculator, I got second tangent, I got 3.54 divided by 6.77, and I get an answer of 27.6 degrees. So this is 27.6 degrees. So my resultant vector is my R vector, which is labeled like this, equals 7.64 at 27.6 degrees. And I could leave it like that, which would be understood that I'm starting on the positive x-axis, or I could just say 27.6 degrees on the north side of east. All right, so now, that's pretty much what we did today, trying to get to the point where you can combine several different vectors, and the simple way to do that is to use the components of each vector, add the x components and add the y components, create a resultant triangle as we did here in the lower left, and then find the magnitude using the Pythagorean theorem, and to find the direction using the inverse tangent. So I will stop here. I will stop my share. If you have any questions, send me an email and I'll get back to you. I'll get back into you tomorrow night and talk about what we did with vectors in the coordinate system. So I will stop sharing now. I will see you tomorrow.